To help you prepare for this Chapter 5 project, I just wanted to wanted to make a quick video just about different types of probability distribution curves. So, in my 5.4 video, I talked about the normal distribution, how that's a classic example of a type of probability density function, a probability distribution. And of course, we spend a lot of time in 5.5 talking about this distribution. Well, what makes something a normal distribution? We talked about this as well, where if the majority of your data is clumped around your average, and then you get less and less likely as you get farther away, it's probably a normal distribution. But of course, there's other types of distributions. So this would be a normal distribution where it's centered, of course, at your mean. But I wanted to talk about just a couple of other distributions, the ones that I specifically ask about on the project. Okay, what is a uniform distribution? A uniform distribution is where all of your outcomes are equally as likely. So instead of having a bell curve, you just have a horizontal line, which just shows that any of your outcomes are all equally as likely. When do we see uniform distributions? This is a great example of this is just random number generators or rolling a dice. The probability of each of your events are all equally as likely. So that's another type of common distribution. Another type of distribution is one that I did an example of this. These are called exponential distributions. Okay, where it's this k e to the negative kx, where k is some fraction under 1. And what do these look like? Well, these distributions are actually bounded by 0, but it's this decreasing function that's flattening out as I get close to 0. And it turns out as long as you have your constants match up, then when you take the derivative of this over its whole domain, you get 1. So it qualifies as a probability distribution. Okay. When do we see stuff like this? These are commonly used for stuff like wait times, where the shorter it is, the more likely it is, and the longer it is, the less likely it is. It's kind of this skewed left idea where it's more likely the smaller the number. So those are the 3 different types of distributions that when you look at your data, I want you to decide which of these fits the best. And honestly, there's a chance that none of these distributions will match your data. And in that case, I'm okay with you saying, none of these actually match. And as long as you explain why. But from your data, how are you going to figure out which one matches? Well, that's where your frequency table and histogram is going to come into play. When you have your data values with their corresponding frequencies, what you can do is you can draw a little dot graph where you're going to put your data values on your x-axis. So this is going to be all of your data values. And then your y-axis is going to be the frequency. How many times did you get those responses? Did you get that response only 1 time? Did you get that response twice? Did you get that response 3 times? And depending on how many times you got it, you can either draw a box or you can draw just a little dot. So if I had data something like this, right? What would that tell me? That's probably a standard distribution. Where my mean is right about here. Okay? What if I have something like this? What if I have a lot of spread out data that doesn't actually repeat? What if all of my data points, all my values all have a frequency of 1? Well, in that case, you can look at, here, I don't want my axis to be right in the middle. So frequency 1. In that case, you can look at if these frequencies clump up as they get to the middle, right? If these, and if you start having spaces as you get off to the sides, if your data spreads out that way. Because if you have something like this, then this would also count as a normal distribution. But if it's all equally spread out, if your data points are equally spread out as you all have a frequency of 1, then that's a good clue that, yeah, that's just a uniform distribution. But once again, there's not really any wrong answer here. I just want you to critically think about your data and make that decision of, what type of distribution is this? Hopefully that helps. And once again, feel free to ask me any questions you have as you're working on this project. But good luck, and I'll talk to you in the next video.